Welcome back to the Skill Staircase, the series dedicated to building your foundational knowledge in technology. In our last two episodes, we mastered the OSI model and the security implications of TCP/IP. Today, we're tackling one of the most fundamentals, yet often misunderstood service on the internet, DNS, the domain name system. This episode, how DNS works, the day in the life of a DNS packet. Imagine trying to call a friend, but instead of using their name, you had to remember their 10-digit phone number. That's essentially the problem DNS solves for the internet. Humans use name like google.com, but computers use numbers, IP addresses. DNS is the massive distributed global phone book that translates those names into the necessary IP addresses. Without it, the internet as we know simply wouldn't function. To truly understand this critical service, we are going to trace the entire journey of a single DNS query packet step by step from the moment you hit enter into that browser. Before we start the journey, let's meet the four key players that make up the DNS hierarchy. Think of this as a highly specialized team of librarians. First, you have the client, which is your browser operating system initiating the request. Second, the recursive solver, often run by your ISP or a public service like Cloudflare or Google. This server does the heavy lifting, acting as your proxy to find the answer. Third, the root name server, the top of the hierarchy, which knows where to find the TLD servers. Fourth, the TLD name server, which handles the top level domains like .com or .org. And finally, the authoritative name server, which holds the final definitive IP address record for the domain you're looking for. These five components work together in a precise iterative dance. The journey begins the moment you type a domain name, say www.stillstaircase.com, and you hit enter. The very first thing your computer does is a local check. Your browser and your operating system both maintain a small local cache of recently resolved names. If the answer is found here, the journey ends immediately. It's the fastest possible resolution. But if it's a new domain, your client sends a recursive query to the configured recursive resolver. This is the critical hands-off. Once the recursive resolver accepts a query, it takes full responsibility for finding the answer and returning it to you. The recursive resolver now has the job of finding the IP. It first checks its own massive cache. If it's a fresh query, the resolver sends an iterative query to one of the 13 root name servers. These servers are absolute top of the DNS tree, represented by a single dot. The root server doesn't know the IP for, say, skillstaircase.com, but it does know which server handle the top level domain, or TLD, in this case, .com. The root server responds with a referral, giving the recursive resolver the IP address of the .com TLD name server. Following the referral, the recursive resolver sends another iterative query, this time to the .com TLD name server. The TLD name server is responsible for all domains ending in .com. It still doesn't know the final IP, but it knows which servers are authoritative for the entire skillstaircase.com domain. Think of the TLD servers as the directory for all the companies in a specific city. It responds with yet another referral, providing the IP addresses of the authoritative name server for skillstaircase.com. This is the final step, the recursive resolver sends its last iterative query to the authoritative name server. This server is the source of truth. It holds the actual A record or IP address for www.skillstaircase.com. The authoritative server responds with a definitive IP address. This is the answer the recursive has been searching for. The entire journey up to this point has been a series of referrals, guiding the recursive resolver down to the DNS hierarchy. With its final IP address in hand, the recursive resolver performs two final crucial actions. First, it caches the answer in its own memory. This is governed by the time to live or TTL value provided by the authoritative server. Caching is the secret to the internet speed. The next time anyone asks the resolver for skillstaircase.com, the journey stops right here at step 1 or 2. Second, the recursive resolver sends the final IP address back to the original client or browser. The browser now has the IP address and can finally initiate the TCP connection to the web server and load the website. Now, let's zoom in the packet itself. The DNS query is typically a small fast traction using UDP, the user datagram protocol, on port 53. UDP is used because it's a connectionless, fast, perfect for quick lookups where speed is paramount. The packet structure is simple but critical. A header containing ID, flags and counts, and a data section with a question and answer fields. For security engineers, the flag field is vital, particularly the QR flag. A 0 indicates a query and a 1 indicates a response. Understanding this structure is key to detecting malicious DNS activity. Because DNS is so fundamental, it's a prime target for attackers. Two major threat exploits the trust inherent in the system. First, DNS spoofing or cache poisoning, where an attacker injects false IP addresses into a resolver's cache, redirecting users to malicious sites. Second is a DNS tunneling, a stealthy technique that uses DNS queries to exfiltrate data or bypass firewalls. The primary defense against these attacks is DNSSEC, or the domain name system security extension. DNSSEC uses cryptographic signatures to ensure that the DNS records you receive are authentic and haven't been tampered with, adding a crucial layer of trust to the entire resolution process. Let's summarize. The entire journey of our DNS packet is a 5-step process. Local check at the browser or OS cache, recursive query to the resolver. 3. Iterative queries to the root or TLD and authoritative service. 4. Authoritative answers returns the final IP. And 5. Caching or connections, where the answer is stored and the browser finally indicates the TCP connection. This entire process, which seems so complex, often happens in milliseconds, making the internet feel instantaneous. And that concludes episode 3 of Skill Staircase. We've traced the journey of DNS packet and uncovered the hidden mechanics of the internet's phone book. If you found this explanation helpful, please like this video, subscribe to the channel, and hit the notification bell so you don't miss the next step of the learning journey. Next time, we are diving into what NAT is and why that matters. Thank you for watching, and I'll see you in the next step of Skill Staircase.